Hello, today we are going to learn how to program Qt applications using the programming language Python. On Google I searched for Qt Python Qt.io. Qt.io is the official website of the Qt framework. This scary website is the entry point, says docs and examples. The technology is called pyside6 or Qt for Python. Official Python bindings for the Qt framework. You can use the Python programming language to write Qt applications. Let's start doing what it says in here. So it says you can obtain the latest stable version by running pip, the Python package manager, install pyside6. So let's do that. So I have created a directory where I'm going to work. Let's name this thing PyQt. Let's start a terminal in here. And first of all, we want to create a venv in here. So Python, in my case, it's Python 3, venv.venv. Okay, let's activate the venv. And now we can run Python command lines. So the first one is pip install pyside6. Let's see what it actually did in here. So there are the packages pyside6, pyside6 add-ons, pyside6 essentials, Shiboken 6, and the packages pyside6 add-ons and essentials are very large because they contain Qt SO files. I'm on Linux, Ubuntu 23.10. So the shared libraries, the dynamic link libraries of the Qt framework are split in two parts. The most essential ones in pyside6 add-ons and the rest in pyside6 essentials. That's why we have these large sizes. Okay, then pyside6 is kind of like a meta package. Let's actually look at the structure on the hard disk. So inside the venv, there's lib python 3.12, side packages, pyside6 essentials, add-ons. I'm using Crusader, the Orthodox file manager, the twin pane file manager. If I press the space key, it's showing me what's the size of each of the directories. So the larger one is lib. And then inside side packages, let's see which is the largest. And pyside6 it is. So pyside6 essentials just contain some text files, whereas pyside6 has this directory that's 430 megabytes in size, where you can find the shared libraries, the dynamic link libraries of the Qt framework inside of the lib directory. So libqt6, 3D, libqt6 core, dbus, GUI, location, multimedia, etc., including web engine. and their dependencies. ICU, the Unicode Internationalization Library. There's also the executables that come with the Qt framework. RCC, the resource compiler. UIC, the code generator that takes as input files, XML files with extension .ui. And then inside of the bin directory, inside of our venv, which is part of the path environment variable, aside from the files which are generated when you create a venv, which are these, there's also all of these executables with names starting with pyside-, which are the executables that you would expect in the Qt framework, such as the designer and linguist for translations. There's also UIC, so pyside6 minus UIC, which converts .ui files to Python source code. Pyside6 minus RCC, which converts resource files into Python source code. Okay, so the official documentation website, web page for Qt for Python for Qt 6 then suggests that we write the first pyside6 application. Let's do that. Says I need to have Python 3.7. And it's 3.12, so that's this prerequisite is met. I am using a virtual environment. I'm using venv. Okay, I'm not using Windows. I did these steps. I did this step. And now I should test my installation. Okay, so it says that I should start Python and run this thing. Okay, so it prints the correct version, the version of Qt and the version of pyside6, which is 6.6.1. Okay, then it says create a simple Qt widgets application. I should create a new file, so let's do that. Ctrl-D, Shift F4. Let's actually try to write. If I just copy paste, I do not learn much. If I actually type, then I will learn more things. Okay, so import sys import random from pyside with this capitalization. Import Qt core, Qt widgets, and Qt GUI. So Python module named pyside6, and the various Qt modules are provided as Python submodules. We are aiming for a Qt widgets Hello World application. Okay. And then it says that I should create this class. Let's copy paste this time. The MyWidget class has the magic member function, this thing, which randomly chooses an item from the hello list, which is this list. When you click the button, the magic function is called, which is, there's a button which is created here, push button, text click me, that is placed inside of a virtual box layout. On top of the button, so vertical box layout, there's this label, which is QLabel with the text hello world and aligned centrally to the window. Okay. And when you click on the button clicked Qt signal slot is paired with the method of the object, which is called magic. And button, text, and the Qt widget are available as members of the object. So QWidget via self, and then self.button for the button and self.text for the QLabel. And now we have the main entry point of the executable, which creates a Q application, creates an instance of the class MyWidget, so the object widget, which is actually a X11 window with a size 800 by 600. The window is being shown, all of its children are being laid out correctly, and then the application enters the graphical user interface application main loop, the Qt main loop, on line 32. Okay, let's see if we can run this application. So Python and hello world. Okay, 800 by 600, and vertically in a vertical box, there's a label and then there's a button. And the label is centered inside, left, right, inside of the window. Let's click on the button. The text of the label will change to a random value out of this array. So there's 1, 2, 3, 4 greetings. Okay, so we have installed pyside6, and we made sure that the installation is correct by running from the Python command line enough commands to see the version of. This was the Qt for Python pyside6 Qt widgets hello world application. Next up is the QML, Qt Quick, so the QML programming language hello world application using the Python programming language. Says that I should create this file. First off, we have imports. Then we have the QML programming language, which we include in a triple quoted Python string literal. Usually the QML source code, you have it in separate files with the extension QML. But in this case, for the Hello World example, we have the QML source code inside the Python source code. And now the main entry point of the executable. This time it creates a QGUI application and a QQML application engine. The QML engines can load QML and render it. And it does app.exec, which is the main loop of Qt, so line 47. After you close the window, the X11 window, then it will go to line 48 and remove the QQML application engine. And we pass this QML source code using the variable QML. In here we go QML, encode as UTF-8 and pass it to the load data method of the QQML application engine. Let's save and see if this thing runs. So Python. Hello world quick. And here it is. Let's run them side by side. Let's look a bit at the source code. So the two windows are different in size because the QML one is 300 by 200, whereas the Qt Quick one is 800 by 600. The array with 4 greetings in the QML programming language read-only property list of string. This QML application has a title in here, whereas the Qt widgets application does not have a title. Okay. And the set text function magic does math random times 3 and converts this to integer. And then it indexes inside of this array and sets that string as the text.text, whereas text is a QML text item. And the button is a QML button item. No vertical box layout, but a column layout. The column layout uses all of the space of the window. When you resize the window, the size of this QML item changes, and that is bound to the width and height of the column layout using anchors.fill of parent. On button on clicked, it executes the JavaScript QML function setText. Let's look a bit with the integrated development environment at these two applications. We could use, for instance, PyCharm. Close the previously opened Python project. Then press the open button. I paste the full path of the directory in this field. Okay. I want to trust. There's two Python files and a Python venv inside of the .venv directory, which is recognized automatically by the Python integrated development environment PyCharm. In here it says that. Let's run the two files in the debugger. I've opened the first one, the cute widgets hello world application written in the Python programming language. Here it is. The integrated development environment does integrated development environment things, such as suggesting that I improve the Python coding guidelines. So in here it says that I should use two new lines. Okay. Let's run this thing with the debugger. Current file and then debug hello world.py. Okay, so QWidgets application. Let's go to definition. Where is this thing? Q application stop. On line 27, we have the declaration of the local variable app, and then it goes QWidgets and QApplication. What are these? QApplication, this is the constructor of the class. QApplication, from QApplication.py from the module QWidgets. If I go to definition in PyCharm, it will go to a file that's generated by PyCharm, Python stubs, pyside6, QWidgets, QApplication.py. And this file is generated based on the shared library, on the DLL of that envelops QWidgets. So there's a QWidgets.so file, which is shared libraries as produced by as part of the Qt framework. But then this is wrapped into a C++ shared object that knows how to export Python modules. So it uses the Python extension mechanism. And then from the files are named qt-widgets.version.so for the shared library from the Qt framework, and then qt-widgets.abi and then a number.so for the wrapper of the qt-widgets.so, the one that exports the Python module. So when you have ABI in the name of a .so file, that's the glue between the Qt shared library and Python. Okay, and then PyCharm comes, takes as much information about the exported Python types from this shared library, and it creates these stub Python files, which are used just for the integrated development environment, just for tooling, just for showing to the user the signature of the methods and the members of a class, etc. So if this file init.py pyside6 Qt widgets is created by the integrated development environment, then which are the files that are part of pyside6? Okay, so in the current directory, we have the vn where we have the entirety of the Qt framework plus pyside6. So we can start Visual Studio Code in here and do some searches. Let's search for Q application. So this thing, we're going to search case sensitively and whole word. Let's see what the results are. So the hello world application that we just created, of course. And then a PEP 484 stub file with the extension PYI, so Qt widgets, the name of the module, and the Python module, and then .pyi. And in here, so this is shipped by Pyside, and in here we have the type hints for the Python classes and symbols. So we know that Q application inherits from Q GUI application. All of the methods that have more than one parameter. The first parameter is of course self, but then the rest of the parameters have type hints, such as this one is a sequence of string. And then also return values. So we have full type hints for Python symbols shipped by Pyside using files with extension PYI. Okay, what else do we have? The Shiboken machinery is present in here. We have the type system files. There's type system widgets common. That says that in the Qt shared object, there's exported a C++ symbol, which is the class Q application, which needs to be made visible to the Python source code using a Python extension module. and then the following C++ header includes will be needed. Some signatures will be a bit changed, a bit different in the Python source code versus the C++ source code. Like this says modify function signature, which is the constructor, makes it private. And then some of the functions exported, some of the symbols exported from C++ need additional C++ source code. And the rest of the methods of the Q application C++ class that are not mentioned here are exported by default by Shiboken. This is a scaffolder, new project. A QML example. Shiboken. Additional Shiboken glue. Okay. At this point would be a good idea for us to look at the package structure. So in here says package content, structure, and tools for pyside6. There's these Python modules that we actually installed via PIP. So we requested pyside6, and it also installed Shiboken, pyside6, pyside6 essentials, and pyside6 add-ons. This thing, Shiboken 6 generator, is not available in the pip repositories. It's another package. So if we do pip list, we'll get this list with different versions, of course. The files abi.so are the glue between the actual C++ shared library, original Qt framework shared library, and the Python world. Okay, so there's also always pairs like this. There's a libqtcore.so and a qtcore abi.so. Okay, we saw the different tools, UIC, RCC, but then also the pyside6 UI minus UIC and pyside6 RCC. So these two generate Python source code. Okay. There's also the file format PyProject that we're going to see in a couple of minutes. QML linter, the graphical user interface application for translating applications, the graphical user interface for application for browsing the Qt help files. Let's continue running with the debugger. So we're on line 27. The line has a blue background. The buttons are step over F10, step into just my code, Alt-Shift-7. Let's go with step into my code. Okay, this is my class. That's why it stepped into. This calls the constructor of the parent QWidget class. We have this field of the class, which is a list with 4 elements. We declare 2 QWidgets, a QPushButton and a QLabel, and then a vertical box layout. Then we put one Qt widget in the other. So inside of the VBox layout, we place in the correct order first the label and then the button. Layout is already connected to self, which is my widget instance, which is an instance of QWidget, which this is actually the X11 window and this one. Okay, and in here we connect a signal slot Qt style connection. So between a event implementation, which is a slot, and an event that's being triggered, which is a signal. So the signal is this one, button clicked, and the slot is this method of the object. Real signature unknown. Well, the signature is probably known because it's part of the PYI files which are shipped by pyside6, but then for some reason the integrated development environment PyCharm does not know yet that it should look into those files and keeps getting from inside the abi.so files the limited versions of the signatures of the exported functions, that the exported symbols that will be made available to Python. Let's see if this is the case, if we can get the correct Python type hints for the method clicked of QAbstract button. So let's open Visual Studio Code in here. We need the QAbstract button, Ctrl-Shift-F-V. So qtwidgets.pyi, that's the correct file to be in. Then we need class QAbstract button, correct. And then the click takes no other parameters other than self and does not return anything. Okay, so the real signature is very known. Next up, let's continue with the debugger. So on line 19, the signal slot connection is being created. Now the X11 window is still not shown, will be shown after line 31. Now it's being resized to 800 by 600, but again, it's not visible. And now it becomes visible. It starts having a X11 window a icon in the taskbar, but the main thread is paused in the debugger. That's why it doesn't get to paint. There's just one thread for now, which is actually the main thread, which is a thread that takes care of repainting and has the graphical user interface main loop, the event, pump, etc. So we need to run appexec. Now the debugger is no longer paused, so we can manipulate the window and it will repaint correctly. If we resize it, or if we move it, or if we press the click me button. Okay, so it hit the breakpoint on line 23. It entered the Python method magic, which will compute a random value out of the list with 4 strings. And then one of these strings will be used as parameter to the set text method, which will actually change the text of the Q label. Okay, and now the debugger is again running not paused. We have new text on the Q label. And that's about it. When I close the application, it will app.exec finishes, returns exit status 0, and then it goes sys.exit of 0, which ends the current process, and the process returns exit status 0, which is success. Any other exit status than 0, positive or negative, integer is a error. Okay, let's look at the other one. Current file debug. It works. Let's put some breakpoints. We cannot put breakpoints inside the string, of course, because it's a different programming language. QML. Q application means a Qt widgets application. That's why the QML application uses QGUI application. So notice Q application, which is the correct name of this class, should have been Qt widgets application. And this is another application, one that does not depend on Qt widgets, which is called QGUI application. This is what we usually use for creating QML applications that do not depend on Qt widgets SO file at all. Okay, but then the application does not know how to display the QML source code. That's why we need a QML engine. Okay, again, this is a Python string converted to UTF-8 and then passed to the load data function. Let's see what the type, what the signature of load data is. So it's from QtQML ABI.so, which wraps the DLL libqt6qml.so. Where is it? This thing. Okay, so on top of the QtQML.so sits the QtQML.abi.so, and on top of it sits QtQML.pyi. And the actual signature of load data, which is a method of QQML application engine. It's a method because the first parameter is self, so it's not a static method. The next parameter is data, which might be a Qt Q byte array, or might be Python style bytes. In this case, it's UTF-8 bytes. And then there's the possibility of the URL where you say, please load this QML file from the disk, for instance. The possibilities are string, the Python type for string, or QURL from pyside6, or from the Qt framework, and does not return anything. This triple dot is what's recommended by PEP484 for PYI files. Let's see that. So I searched for PEP484, which is the type hints Python enhancement proposal. We're searching here for PYI, and says that the concept is named stub files, which are not used by the Python interpreter at runtime, are ignored, but they're used by the type checker MYPY, so the standard Python, the most often used Python type checker, which is a static analyzer for Python source code. And it's especially useful for Python extension modules, which is what we're using right now. And it says that it is recommended that function bodies in stub files should be just 3 dots, like this. Should be just a single ellipsis. If a stub file is found, the type checker should ignore the same file with extension py, if such a file exists. It's possible to have inside of a Python module file system structure in the same directory both a file with extension py and another file with extension pyi, and for instance have 0 PEP484 type hints in the .py file, but have all of the needed hints, type hints, in the pair file, which is the pyi file. Let's continue with the debugger. So it took this Python string, converted it to bytes with encoding UTF-8, and then that was passed to the load data member function of the engine. And the QML source code might be invalid. That's why it has this validation in here. Says after we load a QML source code into the engine, there it's mandatory that we have a root item, a top level item. In QML source code, there can be only one top level item. Okay, and if the QML file is incorrect, the engine cannot determine which is the top level QML item. Root objects will return none. Okay, so this is the return early in case the QML source code is incorrect. Okay, the X11 window has started, but it cannot do anything because the main loop did not start yet. The main loop is this right-hand side of line 47. Okay. I cannot put any breakpoints, for instance, in the method setText on line 20. I can resize, and when I close the window, up exec will finish successfully, no errors, exit status 0. This we store in a local variable. Then we call the destructor of the QML engine. And we end the process by returning the exit status 0, which means success. And we can see in here that the process has finished with exit status 0. Let's continue with the Qt for Python Qt Quick Start tutorial. Next page says Qt QML widgets. Qt was designed, the Qt framework is written in C++, and it's supposed to be used from the C++ programming language. Okay, the Qt framework has many components, so SO files. There's Qt core, Qt GUI, Qt widgets. Let's actually look at those. So venv, lib, python, side packages, pyside, and Qt lib. These things. So this is Qt GUI, lib qt6 GUI.so. There's Qt core, lib qt6 core.so, Qt widgets, this thing, lib qt6 widgets.so, Qt network, this thing, lib qt6 network.so. Each of these SO files export class signatures and other symbols. Qtcore.so exports the following symbols, classes. This is the most elementary SO file from the Qt framework. Let's see what it contains. A byte array, a char. So this is the idiomatic character type for the Qt framework. Q Latin 1 string. Q object, the base type, the base class for all Qt objects. Or most of the Qt classes inherit from Q object. Q string, the idiomatic string type in the Qt framework. This probably stores UTF-16, UCS2 style little endian bytes. Says in here, QString stores string as 16-bit QChars. Each QChar corresponds to one UTF-16 code unit. So this is not UTF-16, this is UCS2. It's the UCS2 is the native string type in the Windows 32 API for wide char. So on Windows, there's three types of strings. There's, let's write this thing down. LP CSTR. This thing is either 7-bit, and then there's LPCWSTR. This is 2 times 8-bit, which is UCS2 on one pair of 2 bits. There's one wide character, which is WCHAR E. This is not how UTF-16 works. Okay, in UTF-16, there is no guarantee that on just one 16-bit on just 16 bits you can represent any strange Chinese character. Okay, so whatever happened on Win32, so this is also the Windows kernel native Windows NT type for strings. And maybe that was popular in the year 94 when the Qt framework has started. That's probably why QString uses a similar backstore for strings in the Qt framework. Okay, so size, this is a pair of X and Y, width and height. A list of strings, a string view, time types, date time, time zones, timestamps, URL base type, globally unique ID, UUID, maybe the most important type in Qt, Q variant, also seems to have a bit of a correlation with the Windows COM variant type. What else? A set. Rectangle with 4 ints, x, y with height. Basic containers. Q. Multi-map, multi-hash. Map. The support for debug log lines. Atomics. And the meta data about symbols, classes, etc. The Q meta object. Q file, the abstraction over files. Using the Qt framework, you can create applications, command line applications that have no user interface. You can create HTTPS servers. You can create graphical user interface applications that use Qt widgets, or graphical user interface applications that use Qt Quick QML, Q declarative. And there's possibilities for creating 3D graphics. You can also create graphical user interface applications that contain a web browser engine, because the Qt framework provides Qt web engine. And then the rest of the graphical user interface you created using CSS and HTML. Is the big two ways of creating graphical user interface applications in the Qt framework are Qt widgets and QML. We just saw them. In QML, you have this specific domain-specific language named QML. Qt widgets is for applications that look like this, with main menus and tabs and scroll bars and panels and toolbars that you can move around like this. Whereas QML is for applications that look like iPhone applications. Okay, we're not going to write both Python and C++ code. When you do that, you'll need a way of either calling from C++ Python code or for calling from the Python source code, C++ source code of yours. So you wrote both Python and C++ code and you want to communicate from one to with the other. Integrated development environment. There's 3 important possibilities. What I showed you before, which is this one. the JetBrains PyCharm, especially the community edition because this is gratis. The other possibility is the Visual Studio Code. Okay, so I've opened in Visual Studio Code the directory. I go into extensions, make sure that Python is installed, and it is. So you find the Visual Studio Code extension that's named ms-python.python and install it. That will install Pylance. What is this? Let's uninstall it. And then let's see what support you have. Go to definition, goes to the correct place in the PYI files that are shipped by pyside. So this is the what Python or what Visual Studio Code does here is way better than PyCharm. We can go to the definition of the module. Qt widgets go to the correct place. Q application goes to the correct place. Set text on the label goes to the Q label set text method, and you can see it's actual correct signature. You can put breakpoints. You can run in the debugger using this tool window, run and debug, Ctrl-Shift-D. You go run and debug a Python file, the current active Python file, that's enough. Stops at the correct place, which is the first breakpoint, line 27. There's local variables, there's the call stack and terminal. The shortcuts are step over F10, step into F11. So step over, and it's stepped into because I have a breakpoint on line 8. Step over. Let's look at hello. Where can we see it? In self hello. Let's make these things smaller. Okay. So there's a length of 4 items. You can see that hello is part of self, which self is of type myWidget. If you hover on type of hello, it says that it's a Python list, idiomatic type. If you hover on top of self, it says that it's the myWidget class, which is this one. Okay. Step over F10. In here, we connect the Qt signal clicked to the Qt slot magic. Okay, resize and now show. But again, the application is anemic because the graphical user interface main loop did not start yet. And now we're going to start it. The debugger is no longer paused. We can do whatever we want with the application. We can click. It jumps to breakpoint 23. It pauses the debugger. Step over. And the debugger is not paused again. And it changed the text of the Q label. So we saw two integrated development environments for Python, PyCharm, Visual Studio Code. Now it's time for us to look at the third one, which is Qt Creator, which is the actual recommended integrated development environment for Qt for Python, so for pyside6. There are templates to create Python pyside6 projects in the integrated development environment Qt Creator. Okay, let's actually look at this integrated development environment a bit. Let's make sure we're using the latest version of the integrated development environment Qt Creator. This is the Qt online installer, which you need to download from the qt.io website. It requires that you have an online account created on the website qt.io, which I've specified in here. Next. Let's see if we have updates. There's Qt Creator 12.0.1, which I have installed, and the latest stable version of Qt, which is 661. Nothing to update. Now we can start Qt Creator. And says that there are projects available, so either create project in here or file new project. And I should select the Qt for Python, which is another name for pyside6. So new Qt for Python, and then window UI file, and then choose. Okay, so window UI file, choose, Ctrl V for the directory name, entitled PY. Next. So there's a class name that's named widget that inherits from QWidget. Let's make this thing main widget. Okay, main widget.py. And then there's this special file format for pyside6, which is a file with extension py project. Pyside6, how does it know? The Python that's available on my machine. Create new virtual environment, correct. Let's put a dot in here. Next. No version control. It will also add form.ui, main widget.py, untitled py.py project. Finish. Okay. It says that pyside6, the PIP package, is not available in the .vnv. Yes, let's install it. It does the exact same thing that we did at the command line when we entered the VNV and then run pip space pyside6. Downloaded the same packages and installed them into the same place or in a similar place. And then it says the Python language server, which is probably a language server protocol, is not available, and it wants to install it in the same place in the VNV, probably also using PIP, which is needed in order to have integrated development environment functionality for Python, but not a debugger. Or maybe it also implements the DAP debugger adapter protocol. I'm really curious to see what PyLS is. So the PyLS, this one, this is only for Python 2. Language server protocol from Microsoft Visual Studio Code for the Python programming language, but other integrated development environments and source code editors other than Visual Studio Code can make use of this language server protocol. This says Python language server. Let's see what it actually does. So install. Yes, that's it. Python minus language minus server. This thing. pip install Python minus language minus server. No, it's Python minus LSP minus server. What is that? So this is a fork from Python minus language minus server. Okay, updated last week. Whereas this thing was updated 4 years ago. Okay, that's why. Okay, so now we have installed Qt Creator, the integrated development environment from the Qt framework. We've run the new project wizard to create a graphical user interface application using Qt framework, Qt widgets, and with .ui file, which is this file. And it looks like this. It's an XML format. Let's actually look around a bit. This is the source code behind the form designer, which is this guy. There's nothing, just a widget, so a X11 window. Let's put something there. Like we had before. So there was a label. Okay, and a push button. And layout vertically. And this thing was, I don't remember what, aligned. So let's look in the Hello World pyside6 source code for the Qt widgets. In here, when it creates the Q label, it specifies a text. Let's use the text also from Q label, this thing. What is this HTML? And it also specifies that alignment is qt core qt align center. So this thing. Alignment on the horizontal align, where are you? H center, V center. Okay, so both align H center and align V center. Let's save and run it. This is run Ctrl R. And we can also put breakpoints. Let's see if that works. May UI form.py form generated from reading UI file form.ui. So in here, the pyside UIC file executable has converted this XML into UI form.py. So this Python source code is automatically generated by a tool. You should not edit it. If you want to edit something, go to form.ui. And then when you run it, it will regenerate the UI underscore form.py file. Whereas this source code is ours, we can edit it as we want. Let's put breakpoints here. Let's debug. Start debugging of startup project. Okay, so it stopped at the correct line, 20 in the main entry point. The shortcuts are step over, let's see, where are they? Step over F10, step into F11, step out Shift F11. So similar to Visual Studio Code. Step over. Now it will step inside of the constructor on line 14, because this is calling the constructor and this is implementing the constructor of the main widget class. Calling the QWidget constructor. And parent is none. Parent being the parent of this X11 window, which, yeah, should be none. Okay. There's this custom in the Qt framework that there's a UI object. If you program in C++ or in Python, that represents the class that wraps the .ui file. This thing. Class UI main widget. This is generated in C++ by UIC, an executable, and in here by the pyside6 equivalent, which is this thing, pyside6 minus UIC in the bin directory in the VNV. Okay, I managed to put a breakpoint inside of the source code generated by pyside6 minus UIC executable. The source code is pretty readable, but again, prepare to never edit this file. Just read it, but do not edit it. Now we're entering the graphical user interface main loop on line 22. No, online on this thing, app.exec online 23. We have the application, we can do what we want with it. There's another main widget. I'm not sure who's created this one. Yeah, maybe when I ran it. So I first ran it and then I debugged it. This is the integrated development environment Qt Creator, which has good support for pyside6. You can edit the source code. You can put breakpoints. Go to definition goes to the correct place, Qt widgets.pyi. The debugger works correctly, but these three things work correctly on the other two Python integrated development environments, because these are not really specific to Qt. What's specific to Qt is editing .ui files. In Qt Creator, you edit inside of the integrated development environment, whereas for the other two integrated development environments, you need to configure that files with extension UI, if you double click on them, will open the executable pyside6 -UIC in order to generate the file UI_form.py and another executable in order to edit it. Which is this application, Qt Designer. So in Visual Studio Code or in PyCharm, if you have the option of right-clicking on a file and open with Qt Designer, right-click on the .ui file and generate Python source code using pyside6 -UIC to generate Python source code. And then you need the same type of running the selected file in an external tool for the files with the extension RC. Those you want to be run in pyside6 -RCC in order to generate a .py file. So either you configure your integrated development environment to have these actions depending on the extension of the selected file, external tools, or for Visual Studio Code, that's this extension shown WU .vscode -qt -4 -python. Or you can just open the correct, run the correct executable for the form.ui file from the command line. I'm not sure how to do that, but it's certainly possible. Where is the terminal in here? Create new terminal. You enter the VNV and then you run a command line like pyside6 -UIC and then the name of the file. Like this. So create a new terminal, enter the VNV, and then in order to edit the form.ui file, we select the correct executable, so pyside6 These are the options. The designer is the graphical user interface application that is the form designer for .ui files. So this is what we want. And the name of the file. Okay, you don't really need all of the fancy right-click actions when you select a file from the file tree view. You could just navigate with the terminal there and run pyside6 minus designer space and then the name of the file by yourself, by hand. Next up, let's look a bit at the magic behind Qt for Python for pyside6, which is called Shiboken, which is a solution that's implemented by the team that implements Qt for Python pyside inside of the Qt group. So it's built on top of the LLVM, CLang, C++ compiler library toolchain. So as input, there's the Qt headers. So the Qt libraries, the Qt framework comes as .so files, which are shared objects dynamic linking libraries, plus the C++ header files, so .h files for using inside of the C++ statement # include. And then those Qt headers have the full C++ signatures of the exported symbols from the SO file. And then Shiboken knows how to create a CPython extension. So a C or C++ .so file that the Python interpreter knows how to load and run and see as an additional Python module. But then some of the signatures inside of the C++ headers, you want them to be a bit modified when they arrive in the Python extension.so file. And for that, there's this XML configuration file, which is called type systems, where we saw that the signature of some methods was changed by making it private, for instance, or additional C++ code was needed in order to change a bit the implementation or the signature of a C++ exported symbol. Okay, so it's a solution built in-house. It uses the best C++ parser, which is also used by the C++ compiler CLang++. There's been more than 5 years invested into implemented pyside and then pyside2 and now pyside6. There's more than one full-time paid developer by the Qt group working on pyside6. The next page of the tutorial talks about the file types that we will encounter. Let's actually look in the Qt Creator project. So the file types that we can see in here are extension.ui, which is this file. There's QML files for the QML programming language. There's PyProject, which is this thing, a JSON looking like project configuration file. This should be included in your Git repository. It just lists all of the files. Mainwidget.py is the entry point Python file. And then form.ui, which Qt Creator will know it needs to be converted using pyside6 -uic into a twin file, so form.ui, and its twin ui_form.py. Then there's QRCs, which are resource files, which will need to be compiled using the other tool, pyside6 -rcc, to generate the Python source code. Okay, we saw the .ui files, which is this thing, or this thing. Okay, we saw the pyside6 UIC tool, takes as input a .ui file, generates .py file. There's resource files, .qrc files. There's the executable pyside6 -rcc generates Python code. QML source code lives usually in files with extension.qml, and then these files might need other .qml files, might need QML modules, my QML dirs, might need .js files. Okay, and the project file for Qt Creator and Python is with extension PyProject. Used to have the extension PyQtC, was just one line with on each line there was just a Python file. But now it has changed extension from PyQtC to PyProject. It's no longer a one file name per line in the plaintext file, but it's a JSON file. Okay, top level element is a property files with an array of files, of strings. So Qt for Python does not support WebAssembly and Android and iOS, which are supported by the Qt framework for C++. Okay. On embedded non-mobile phone systems, there is the possibility of building your application. That's using pyside6. Okay, then because it's a Python project, you will need to think about how all of the developers in your organization will use the same Python pip modules in their virtual environment. Solutions for that would be pip install -r requirements.txt or pip env. Okay. Qt is a very popular programming language. The C++ source code is a bit more verbose than the Python source code. And now the tutorial, the getting started guide has finished. The quick start has finished. And we're on the next tutorial, which is called getting started. Let's see what this thing is about. It's focused on building Qt for Python from source. I do not ever want to do that. I want to go pip install pyside6 instead. I do not want to do a cross compilation. For instance, build on an AMD 64 machine for ARM 64 machine. What else? Getting started on Linux. Building from source. I do not want to build from source. Requires libclang. I do not want to build from source on macOS X. macOS. Neither on Windows. Microsoft Visual Studio 2002. And clang. libclang. Okay, so we talked about the structure of PIP packages. There's tools, UICRCC, pyside6 -uic.exe. There's also an executable pyside6 project that knows how to build .py project files. That's interesting. So pyside6 project, this guy. Build, clean, run, lint, deploy, and new. So scaffolding, creating new projects. And then the name of a file with extension PyProject. Creates an executable for the corresponding platform. Takes all QRC files and generates rc_name.py files. Takes all .ui files, generates UI_name.py file. QML dir, QML types. Interesting. A linter for QML. For internationalization translation. Let's see this thing. pyside6 assistant. Which I do not know how to use. Okay, another one, pyside6 minus gen pyi, which is probably used to generate the extension pyi that we already saw, the Qt widgets.pyi file. Generates Python stubs for Qt modules. And a tool for generating desktop applications for deployment, Linux, Mac OS, and Windows. And a tool for pyside6 Android apps. Okay, so the order was pyside, then pyside2, and now pyside6. pyside2 was for Qt5, pyside6 for Qt6. This is how a Python module in pyside2 looks like, and this is a Python module for pyside6. QML Qt Quick for the QML programming language, and Qt Quick widgets for QML, but creating buttons that resemble the Qt widget Q push button, and creating main menus that resemble the ones from the Qt widgets. No, that's Qt Quick controls. Qt Quick widget is to have a inside of a Qt widget application, a rectangle of your application to be actually a QML engine. All of the Qt modules. PDF viewer. Qt Quick controls, these ones were Qt Quick controls, QQC 2. So Qt Quick applications, QML applications look like a bunch of rectangles and other graphical items, whereas QQC2 applications tend to look like classic desktop applications. Okay, I do not use Qt3D. What follows is the listing of Python modules, and then from each Python module, the symbols that are exported there. So it starts with pyside6.qt3d animation. These are the symbols that are exported. Q abstract animation is the first one, with all of its Qt things. So functions, which means methods, properties, which are actual Qt properties, with the machinery behind them. So getters, setters, event when unchanged, observer, etc. Okay. Slots and signals. So signals are similar to events in other graphical user interface programming frameworks. And slots can be used as event implementations. So for instance, when animation changed, you can call set position. Unfortunately, there's no Python source code available for QAbstract animation. There's this documentation which was based heavily on the documentation of the C++ class QAbstract animation. We know the signatures, the exact signatures, because we have them in the PYI files. Let's look there. So Qt3D animation.pyi, the name of the Qt module.pyi, gives us a as good as possible signature for all of the exported symbols from this Python module Qt3D animation. But still, we cannot see the actual implementation of the methods, constructors, static methods, destructors, etc. Functions, free functions. We see their signature with Python type hints, but not the implementation. The implementation is actually C++ source code that glues and calls a libqt6 3D animation.so file. So the actual body of the methods and constructors, etc., is actually C++ source code in the Qt framework. And that's a problem because without actually looking at the body of a method, just reading the documentation and the function signatures sometimes it's not enough, because let's pretend that the function signature is actually correct, but then how much can you trust the documentation that was written by humans, that was actually written for the C++ source code and then imported using semi-automated tools into this file. So this documentation that talks heavily about the body of the functions is a bit of help, but then the actual source of truth is going to be the C++ source code implementation of the method getter of property position. Okay, so this was the modules API chapter in the doc.q.io/qt for Python -6. Next up is tutorials. Let's do some of these. And then there's also the Qt widget gallery. So the tutorials are for Qt widgets, for QML, and there's also instructions on how to use Qt Creator's QML debugger in order to debug JavaScript source code from the QML files. So let's see what it says in here. It says that you should use Qt Creator to have a QML application using pyside6, but then at the entry point, you need to prepend this part. Let's actually do that. Let's start Qt Creator. Let's create a new project. Qt for Python, Qt Quick. Choose in this directory. Make it QML D for debug. pyside6, Python 3.11.6.venv. Okay, there's no JavaScript in this QML file. There's just one QML file, main.qml, no JavaScript. But I know where to find Python plus QML plus JavaScript in the first example that we have created, which is this thing. Okay. Let's copy all of the QML source code into main.qml, trailing new line, save. And we're interested into breakpoints on lines 15 and 16. Let's save. It's already saved. Let's run. No module named pyside6. It says that I should install inside the venv Python language server. Yes. I should install pyside6. Yes. And now let's try to run the application. Works correctly. And then the instructions say that I should add this part at the start of the application. Let's do that. So starts with argument parser, options, an if, which does QML debugging, enable debugging, and then the rest of the application. Up is QQuick or QApplication, etc. Then we need additional instructions on how to use the QML debugger in the IDE Qt Creator. Says for more information about all the options you have, debugging Qt projects, let's go there. Says setting up QML debugging. First of all, we need to set in here in QML debugger should not be automatic, probably should be enabled. Let's see that. So that's projects, run, debugger settings, QML, make this enabled. And then this thing, starting QML applications. by hand to debug already running applications. So I'm going to start the application from the terminal because this way I know the application will start in the correct venv and with the correct command line, which is this command line. So let's do that from this directory. CD Ctrl-Shift-V. Enter the venv activated. And now we need to run the application. So the application is named main.py, so Python main.py, and then this thing. IP address is optional. Let's see if we don't put anything there, if it's okay. Port 4455. And then this block thing says it's optional, prevents the application from running until the debug client connects to the server. So block is actually mandatory, not optional. Okay, let's see the application running. It did not run correctly. Why not? Because it's not saved. File save all. And even more, what is this thing? We didn't copy paste correctly. So says that we should copy this part. Argument parser. Okay, and then it complains that there's no QQML debugging enabler. Let's see who's this thing. Search on Google always starts with pyside6 and then paste. Okay, it goes to the correct web page, which is doc.qt.io, Qt for Python 6, pyside6, QtQML. Okay, so QQML enabler is a class from the Python module QtQML. This guy. So we need to add it here. Okay, now it sees this symbol. Again, Python main.py space minus QML JavaScript debugger, JS debugger equals port colon 4455, comma block. And now the QML debugger has started correctly and the application will not continue running. It stops somewhere before line 18, I guess, until, or maybe in the main loop, until we can connect to the application from Qt Creator. Let's do that. In Qt Creator, we have the same application open. And now we should follow the instructions, which says step 2, start the application with the correct command line, which we did. Step 3, from the Qt Creator main menu, debug, start debugging, attach to QML port 4455. Okay. And it works correctly. As you can see, I have 0 breakpoints in Python source code. I have 2 breakpoints in QML source code, actually in JavaScript source code, because this thing is JavaScript. And I also have in QML debugger console the option of executing JavaScript inside the JavaScript engine, inside the QML engine. Let's see what that looks like. Okay, so math.random works. Math.random times 3 works. Math round of this thing works. Up arrow enter works. What do we have here? Clear. Warnings, info, errors. It says that now we're inside the set text JavaScript function. That's the context. We have this text. What is it? It's an object. We can expand it. So it's a JavaScript object with these, I don't know, properties, ton of them, which we can change if we want. So let's see, let's change the text. Text dot text equals we. It's not applied in the UI because the main loop is not running. Okay. Step over. Step over. And now let's try to set the text. And continue for QML. And now we can see the main graphical user interface loop has run and it has applied correctly the string literal we to the text of the label text. Let's see if we have a self. Nope, a this. This is probably the first argument, the one that's invisible inside of set text. Similar to self in Python. Okay, we can do all sorts of things. We can increase the width and height. So width and height with 300. And let's make it 500 by 500. It tried to apply immediately, but again, the application's main thread is paused in the debugger. And now the X11 window is a rectangle, hopefully. Okay. We can continue running. Let's investigate this Y local variable. So it says the type, it's a number, doesn't say the value, it's 2 or what it is. qstring help browser inside of the Qt creator for QML. There's help for the text property of the Q label, this one. Text item. Yeah, text is actually the label type in QML. So this is not a Q label, but a text QML item. And the property is text. Okay. But then it doesn't know that text is of type text. Somehow. So we need to search it in here. Text QML type, this guy. Okay. Layout alignment. Okay, help works correctly. For the identifiers, symbols from QML. Okay. In order to evaluate and see what's the current value of I, we either use the QML debugger console, which is Alt 8, or we have the inspector. Let's see where that thing is. So this tool view, the watch, where we've put the I, knows that it's a local variable, knows that it's in JavaScript in QML, knows its value and type. Okay. There's inspecting elements. While an application is running, you can use the locals view to explore the QML item structure. Where is that thing? This thing. Okay, so from this button, views, or the debugger, you have stack, breakpoints, threads, modules, source files, local expressions, registers, debugger log, editor, etc. So we have locals. We just saw that inside of line 15, there's a parameter passed through the method, which is not named self, but named this, which is this thing. This is available in the locals view as a tree view where we can expand. And where we can probably actually change the current value of the properties. So let's try to do that. Go to line 17. Go to text. Where are you? And now we're in the window, we're not in the text QML item. So we need to go to text, which I do not see where it is. Locals. So we've exited the method. It's too late. Let's run it again. Step over. And click the button again. And now this in locals is the I'm not sure how to get from the local variable this, which is this window, how to get to text. What I need to expand in this tree view, in this tool window, in order to get to the text with ID text. But I can see that the title of the window, so this is actually the window, has a title. Let's change the title. Hello now. And the title will change for now. Again, the application is paused, so it's not that responsive. Let's see if this thing works. Says you want to keep the application that you're debugging visible. Debug, show application on top in the Qt Creator main menu. So debug, show application on top. And click me. Interesting feature. So I is not defined on line 15, will be on line 16. We can edit the text probably, but I do not know how. Like this, and add a 1 at the end of each. Nope, it's a read-only property list string. Cannot edit it. Okay, let's stop everything. So stop the application, Control C. How do we do it? Like this. The graphical user interface application. Let's let it run. Okay. When we clicked on the close button in the title bar, the application received the message that it should stop, but then because it was the graphical user interface main loop was paused in the debugger, it did not take that message and do what it should do with it. But then when I restart, when I told the debugger to not be stopped, the application has closed correctly. Okay. And also the debugger in Qt Creator has closed correctly. Debug select to activate selection mode and then click on item in the application running. Oh, I don't know, let's see this thing. Sounds interesting. Start, attach, don't show again. It remembered debug show application on top. Okay. So I have it in locals. Let's go there. This thing. Select the item in the code editor. Which one? This one? No, this one. You can view a QML item in the locals view in the following way. Expand the item in the object tree. I'm not sure what that is. This thing. You can view HTML items in the local view in the following ways. Expand the item in the object tree. Select the item in the code editor. It's selected. And then the third way, select debug select. Debug select. Let's see what that thing is. Debug select. This is very, very interesting. So this is the locals view. And you can expand the tree view in the locals view if you're inside of the QML debugger, but not stopped in JavaScript. Let's stop in JavaScript. So there's actually at least 3 different debuggers in the same debugger at the same time, depending on where you are. Right now, this is the JavaScript debugger, and this does not allow me to go from the Qt Creator main menu, debug, and then select. In the locals, it shows me only the local variables. So there's this, and then will be an I. This and I. If we're not in the JavaScript debugger, then we're in the QML debugger. In order to, this shows the parents, the Qt parent relationship. So the text is inside of a column layout, which is inside of a window. If we give them IDs, then instead of the type, like in here it says column layout type, it will say the ID. So let's put IDs everywhere. Camel case. Okay. So there's the top level QML Qt Quick object, which is the QML application engine, which is, where are you? This thing. And then inside there's my window, which is this QML item. And in there, there's the column layout, my column layout, which is this QML item. And then to immediate children, my text, this QML item, my button, this QML item. Okay, this way we can have both the project structure tree view and the QML outline tree view visible at the same time. If we select an element in the outline tree view, it will select it in the text editor. Let's look for my text. This thing. We can edit it while the application is running. Okay, and then using select, debug select, we can inspect the application similar to what KDAB gamma ray does. So button with a label mnemonic label. This is the internal implementation of QML item button. It contains a background, a Q-Quick pen, a rectangle, a mnemonic label, and support for screen readers and other accessibility software. Okay, so this is providing a ton of power for inspecting the QML running application. We can see exactly what QML items really exist in the structure of, in the tree view of QML items that are present on the current X11 window. By expanding in here, some of the properties can be changed real time. It also navigates a bit in the source code editor. There's functionality for clicking and double clicking. So click selects the item, double click selects the, I don't know, the parent or something. And then there's also the support that we saw previously for debugging Python and debugging JavaScript inside of QML.